exercise A01 is going to have us revisit the Andy array library. We are going to add a couple of functions, as you can see here in this exercise sheet. The first couple of functions are going to deal with memory allocation, so this is going to be our opportunity to practice what we learn with the malloc and free system calls. And then the other functions, starting with int array clone, gather, and extract, are going to be an opportunity for us to leverage the function dealing with allocation of dynamical integer arrays to do duplication of an array, to concatenate two arrays with one another, and to extract a subarray from an existing array and allocate it in its own memory. So we are going to get started by the first function, and all those functions will integrate in the files hal.h, hal.c, and test.c. Okay, so the first one is going to be the int array allocate, which has a very relatively easy signature. So we are going to go in the hal.h file. We are going to cut and paste the prototype. There we go. Int array allocate int size. While I'm at it, I'm going to go ahead and I'm going to cut and paste all the prototypes that I'm going to develop right now. So we are going to take care of the allocate function, we are going to take care of the deallocate function, and we are going to take care also of the deallocate cleanly function. And I will explain as we implement them what is the difference between deallocating and what I refer to here as deallocating cleanly. So let me save hal.h. For now, I'm not going to add any test. So I'm going to leave test.c alone for a while. And I'm going to go to hal.c where I'm going to actually implement those functions. So let's get started with putting all those prototypes. Actually, I'm going to go fetch them from hal.h. That would be easier. I can fetch 3 of them in one shot. There we go. And I'm going to here put empty body for those functions. Those functions which require a return value, I'm going to put an arbitrary one right now, just so that the function compiles appropriately. And I realize here that I've been mixing two styles of curly bracing, so I'm going to rectify this right now. Okay, the first function is an allocate function. Well, right now I'm going to make it return null. The second one, deallocates. If you look at the exercise sheet, it's going to tell you when there is an error situation and what you need to return. So int array deallocate, it's going to call free, blah blah blah, make sure, blah blah blah. If the deallocation went fine, return 0, otherwise return -1. And the same will go for int array deallocate cleanly. So we are going to assume that there was a problem. So I'm going to return -1. Oops, -1 here, return -1 here. Okay, so right now we are pretty much ready to compile empty shells. So what we can do, we can save this file, go to Conqueror, gcc hal.c test.c, and make sure everything is fine syntactically. It is. There's no point in running the test right now, since we didn't really add any code and we didn't even call the code that we didn't add. So we're going to now start working on int array allocate. So let's have a look back to the questions, original question. You are going to return the address of a newly allocated dynamical array of size integer. Size is the parameter of our function. Null, if size is negative or null, or if malloc didn't work. So we are going to have this int array allocate function serves as a wrapper around a call to malloc. So here's how we are going to do things. First, we get rid of the error situation. If size is actually lesser or equal to 0, then I want to return null. Then I'm going to call with a pointer p, I'm going to call malloc, p equal malloc size of an int times size, that is how many integers I want in my array. And if p equal null, well, return null, which I could simplify by simply saying return p. Okay? Which I could simplify further by saying just return return the result of calling malloc, etc. If the malloc didn't work, malloc will return null, which I'm just going to pass to whoever called me. And this makes for a very small function here. Let me try to compile this. Implicit declaration of function malloc, return max pointer from integer without a cast. So these are warnings. Let's go back to the code. What happened here is that I don't have actually the library to be able to use malloc. So stdlib.h is going to be added here. Let's save. Go back to Conqueror and see if that fixed our problem. That totally fixed our problem. So the second warning was actually about the fact that because the prototype of the function malloc was not available, the compiler made assumption about the return type of malloc. Assumption is generally int. And then, based on that, I can go back to the code. Based on that, what was returned here was supposedly an int, expected to be an int, and I wanted to return an int star. So that was causing the problem that you observed. So we're going to go ahead, and because those functions are really small, we are going to write in one shot inter-array deallocate and inter-array deallocate cleanly as well. So let's go back to the exercise specification. This function we call free. So the same way that allocate is a wrapper around a call to malloc, deallocate will be a wrapper around a call to free. We deallocate the dynamical array, which address is passed to as its parameter. We have to make sure that P doesn't contain null. So this is an error we need to handle. If everything went fine, we return 0. Otherwise, we return -1. So this is going to be a very short function as well. Let's try to detect error situation first. If P equal null. If P equal null, if P equal 0, if P is false, this is really what we're writing here. So I could simplify this expression by writing if not P. If P is different than 0, not P is going to make it true. Okay, therefore I'm going to return an error here. So my error is return -1. That's fine. Now, if I got rid of the case where P is null, I can now work on returning the result of a free. Well, the free function doesn't return anything. So instead, I'm going to have to call free P. And I'm going to have to assume that at this point everything went fine and return 0. Okay? The malloc function always return something, the address or null if there was a problem. The free function doesn't. So there are other ways to try to check if everything went okay when using malloc and free. We're not going to get into that right now. We're just going to assume if I didn't have to deallocate a pointer that is actually null, then the deallocation worked. What about deallocate cleanly? Well, as you can see here, when you call deallocate, you pass actually the address of the dynamical array that was allocated. When you call deallocate cleanly, you pass the address of the pointer, which contains the address of the dynamically allocated array. So why do we do so? Well, just so that we can here set that pointer to null after doing the deallocation. So first, I'm going to reuse the code I already wrote. I'm going to call inter-array deallocate, and I'm going to call it on star P. Why star P? Because star P, P being the address of a pointer, star P is the pointer itself. So I'm passing the content of the pointer itself, which is the address of our dynamical array. Now, once I call this, there might be a problem there. Okay, I might detect that, for example, star P contains null. So in this case, I'm going to have to detect this int result, and result is going to be the result of calling inter-array deallocate star P. Once I know what is the return value of calling inter-array deallocate, I can check it. If result equal -1, something went wrong. Therefore, I'm going to return also -1. Otherwise, what do I have to do? Well, if I didn't return -1 because star P contained null, then I'm assuming that star P was properly deallocated. And then I want to set to null this pointer, which address was given to me here. So this is why I call it deallocate cleanly, because after you are done deallocating the content of your pointer, okay, the address Sorry, let me rephrase that. The dynamical array located as the address contained into your pointer. You are capable here to modify the pointer itself because you were passed its address to assign it to null, thus preventing anyone from ever using that address again. You deallocate the address given in the pointer and you clean up your pointer. Sorry about that. Okay, so now we're going to save. We're going to compile those different functions. Okay. Warning, line 23, control reaches end of non-void function. Let's have a look. Line 23. I forgot the return. So if everything went okay, return 0. So this is what this error message tells me, okay? I'm going to compile again. Let's see, it's working now. So still no point in running it because I didn't modify test.c. Now I can go to test.c and I'm going to have to make up a function which I'm going to call test int array dynamical for dynamical allocation. And I'm going to call this series of tests at the end here dynamical. Now I need to come up with just test. So void test int array dynamical. I'm going to test all the functions that we just wrote. So to test them, I need something such as int star p. And then I can start allocating p equal int array underscore allocate. I want an array of, let's say, 3 elements. Okay, so I allocated this array. First thing I can do, I can check if p equal null, which I could write if not p. If p equal null, I have a problem. So I'm going to display an error message, and I'm going to use the same kind of way of displaying error message I used in the past. So where am I? I'm here. I'm going to do a printf. I'm going to do a printf of error int array allocate function. So that tells me which function is actually having a problem. And I could be like more explicit, like saying that it returned null, but right now this is the only error I'm capable really on detecting on that function. So now that I've done my little error detection here, I can try to deallocate. Okay, so before even to go to deallocate, sorry about that, I'm going to spend a little more time on the allocate. I'm going to try to allocate actually different pointer, and I'm going to try to actually allocate pointers which are of size 0, of size negative. Allocate dynamical array which are of size 0 or of negative size. So I'm going to take 3 pointer instead of the one I had so far, okay? P1 will be an allocation of a regular array. So error int array allocate function. So I'm going to be a little bit more specific. Int array with parameter 3. Function didn't work. Then I'm going to test P2. P2 will be the pointer that is assigned a dynamically allocated int array with a size 0. So if I call, once again, let's go back to whole.c. If I call allocate with a size which is 0 or less than 0, I return null. So I'm going to come back here, try to call with this, and I'm going to check if P2, I don't know why I wrote P2 here, if P2 is different than null, then I'm going to do my printf. Why? Because I expect P2 to be null. This is what I need. So int array need to tell me no way I can allocate something of size 0. So there we go. The null case is handled, and then I'm going to do P3 array allocate -3. Why not? And I'm going to test if P3 different than null. Printf error int array allocate of -3 function. So out of all those calls, if I am correct, out of all those calls, P2 is going to be the one containing null, P3 is going to be the one containing null, and P1 will point to an array. I'm not going to chain more tests here. Okay, for example, here, if the allocation didn't work, etc., I'm just going to keep going and try again. All right. What I could be doing is, as soon as, for example, I trigger this error, well, I could exit my code. I'm not going to do that. Another thing I could be doing is, if I was returned actually some memory here, deallocate it. Okay, deallocate it to make sure that by the end my program stops. I don't have a memory leak. Well, I'm not going to do that either for the following reason. In this program, this test program, I'm going to run it. It's going to run in something like, I don't know, 5 seconds, and maybe it will cause memory leaks indeed, if the code is not working properly. However, if the code was not working properly, I got error message here that are going to tell me there is a bug there. So as a consequence of that bug, there will be a memory leak. Instead of devoting my time trying to handle the memory leak, I'm just going to detect the bug. And then it will be the role of the programmer that has to fix that bug to say, well, if I am return value here, that can cause memory leaks in other applications. So I'm just going to address the bug at its source. Okay. Once the bug is fixed, this program will not cause any more memory leaks ever. So we have P1, P2, P3. Okay, now I can keep working with P1 at that point. Okay, if P1 equal null, I displayed an error here. So I'm going to assume that now I have something different than null. And actually, for this one, I'm going to stop if P1 is null. So I'm going to reiterate my test here. I could write that like more compact, but that doesn't matter. If P1 equal null, then I'm going to do an exit, let's say 1. And I'm going to indicate I cannot continue the test further. So brace, printf, error, cannot continue with null P1 pointer. And then exit 1, close curly brace. Because I used the exit, I'm going to need here in addition of stdio.h, stdlib.h. There we go. So now that I know that past this point P1 is not null, so I can play with it, I'm going to try to deallocate it. So I'm going to deallocate it by calling int array, deallocate first. I'm going to pass P1 as pointer. When I try to deallocate, I should get a return value, which is, let me double check the code, deallocate is going to return 0 if everything works fine, -1 otherwise. So let me use here int result equal int array deallocate. Okay. If result equal -1, then I had a problem. Printf error int array deallocate with P1. Okay, so at this point, I tested trying to deallocate a valid pointer. Okay, I assumed that P1 was valid. Let me try, assuming that of course the allocate function worked. Let me try now to deallocate a pointer which I know is not valid. Result equal int array deallocate. No. We explicitly cover that bug, right? So in our function, so if result is actually different than -1, that means my function completely missed detecting that bug. Okay, printf error int array deallocate null. So I covered the case where I'm expecting result to be different than -1 because P1 was valid. Then I cover the case where I expected the result to be -1 because I passed null to deallocate. Now I'm going to try to test deallocate cleanly. In order to be able to test deallocate cleanly, I need once again to call int array allocate with 3, okay, a value which I know is valid, and then I'm going to try to deallocate it again. So I'm going to call, and I'm going to do a giant cut and paste here, because I'm going to test two same situations. I'm going to start by calling int array deallocate cleanly. That should get rid of P1. Okay, if the result is not what I expected, I display an error, int-array deallocate. Oops. Okay, controller rows is not playing nice with me. There we go. Cleanly, and then I'm going to try to call it again. So deallocate cleanly, but with null, and I'm going to update the display as well. One thing I need to change, the interface of deallocate cleanly is different. I need to pass the address of a pointer. So I handled the case where my pointer was null. Okay, the pointer contained null. How could I pass here the address of null? I can't. So what I can do instead is, since I deallocated p1, assign p1 to null, and then call my function with address p1 and let it detect that p1 was actually containing null. But that brings an interesting situation. What if I try to call int array deallocate cleanly with null directly? Well, this is not handled in the code. So I'm going to differentiate those two cases. This one is a case where p1 is null. Let me rewrite it with null p1. And this is a case where I pass directly null. Let me save this file. Let's go to the code. Let's see how we handle this. Well, when I try to deallocate cleanly, I first call int array deallocate star p. So I don't even verify that my star star p parameter is actually valid. So let me check that now. If p equal null, don't go any further. Return -1. Let's save. Go back to the test. So writing the test actually helped me designing the function, and this is not something that is unusual at all. So I have now a test int array dynamical function. It tests a couple of things, everything you could think of about those dynamical allocation function. Let me go back to Conqueror. Let me compile here. Hall.c line 21 syntax error before int should be easy to fix. Hall.c line 21. There we go. It's missing semicolon. No sweat. Save. Conqueror. GCC again. This time it's working, and now I can test it. A.out remembers the convention of our test.c programs. If they don't display anything, that means everything was working fine. So pretty much, I'm going to pop up the test again of hall.c. These functions are actually implementing allocation, deallocation, and deallocate cleanly. Little note here, there are a couple of questions in the exercise sheet that invite you to think about how we could catch in our test.c function all those little errors that are common with pointer. Well, ask yourself this question, look it up in the textbook, and post forums question if you need help with it. This is actually an open question that leads us to things that are not necessarily critical to this course, but that are going to be useful for you to understand as part of you becoming careful when using pointers. Okay, you need to understand what are the limit of what you can test and when you have the need for external tools.